In this video of your IR lecture series, we will be looking at the IR of our carbonyl groups and nitro group. Previously, we looked at our carbon-hydrogen and our carbon-carbon bonds. We also looked at our alcohols and our amines. When looking at our carbonyls, we have a lot of carbonyls to look at. You can see the carbonyl groups go from around 1800 with our acid anhydrides down to about 1675 with our amides. And they're listed here in the order from the highest wave number decreasing. The anhydride shows up in two places. Anhydrides are 1810 to 1760. Acid chlorides are around 1800. Esters are around 1735. Aldehydes are around 1725, ketones are around 1715, carboxylic acids are around 1710, and amides are around 1675. Your carbonyl stretch, your C double bond O stretch, is generally a very strong stretch and tends to be much stronger than your carbon-carbon peak. As you can see, all these stretches fall really close to each other. And these are just kind of the middle of the ranges. So the ranges for all these different peaks tends to overlap. And if there's conjugation or electronegative atoms near it, that will shift where our peak shows up. So looking at our carbonyl compounds, we tend to have to look at our other parts of the structure besides the carbonyl. So let's get started. First, looking at our ketone versus our esters. Ketone is a carbonyl of last resort, is what I tend to like to call it. So you have to eliminate all the other carbonyls before you decide you have a ketone, since the only distinguishing factor about a ketone is the fact it has that C double bond O. That C double bond O shows up between 1708 and 1720. An ester group is a carbonyl with an OR group attached to it. So that carbonyl will show up around 1735 to 1750, and your carbon-oxygen single bond shows up between 1100 and 1300. So you can see, looking at our two spectra and comparing them, highlighted in green here is our carbon-oxygen single bond that we can see in the fingerprint region. And we can see we don't have any strong peak in the fingerprint region here. This is how we can determine the difference between a ketone and an ester. You have to look for that carbon-oxygen single bond. So now looking at an aldehyde. Aldehydes have a carbonyl peak around 1725 to 1740. They also have a CH peak that's unique. The unique CH peak shows up between 2700 and 2760. There's also a second peak between 2800 and 2860. These two peaks occur because of Fermi resonance. The CH aldehydes tend to be too broad or broad-ish peaks. And you'll usually see is kind of these two peaks here. It can be a stronger peak like this, or it can be a weak, kind of a weaker peak. But you'll still see those two distinguishing peaks. Remember, the carbon-hydrogen sp3 peaks start at 2800 and go to 3000. So when you're trying to determine if you have an aldehyde, look for these CH peaks. That's your distinguishing structure and your distinguishing peaks in your IR spectra. Carboxylic acids. We looked at this a little bit in our last lecture. We're going to look a little closer now. Our carboxylic acids tend to be a very easy peak to see. We have our carbonyl peak around 1700 to 1730, and it tends to be a strong peak. The CO peak shows up around 1200 to 1320, and that tends to be kind of a medium intensity peak. I've highlighted that in blue, in the blue dash here. The OH peak is a very broad peak. The last one we saw on our previous lecture showed the peak coming down and taking up a good part of the spectra. The carbonyl OH can also look like this, where it's just a small dip down in our spectra. And I've highlighted in the green dash for you to see. So we can see our carboxylic acid OH will either be an extremely large peak that takes up about half the spectra, or it'll be a smaller peak, a much weaker peak like this. But that OH is your most distinct peak to determine you have a carboxylic acid. Always look for that OH to tell if you have a carboxylic acid or not. So now looking at our acid anhydrides and our acid chlorides. These are two more unique functional groups that we tend not to see very often. And that has to do with the stability of the molecules themselves. We've learned in Chem 112b that our acid anhydrides and our acid chlorides are the two most reactive functional groups, or carbonyl derivatives. In your acid anhydride, since it has two carbonyls in it, we draw acetic anhydride here. It has two carbonyl groups, so we're going to see two peaks, two carbonyl peaks. And they tend to be between 1740 and 1770, and then another peak from 1800 to 1830. So you can see we have two carbonyl peaks present in our spectra here. We also have a CO single bond. That shows up anywhere between 900 and 1300. It is still going to be a strong peak. So you can see that right here. But it's these two higher wave number peaks that distinguish the anhydride from any other functional group. Acid chlorides is also a more unique functional group that we tend not to see very often. But IR is a wonderful tool for figuring out acid chlorides. IR tends to be one of your better tools for figuring out acid chlorides. Because acid chlorides are so unstable, trying to take an NMR usually results in the acid chloride decomposing into a carboxylic acid. Taking an IR lets you get an instantaneous view of your sample. And the acid chloride will have usually a very high frequency carbonyl peak, somewhere between 1775 and 1810. And then you should also be able to see the carbon chlorine peak, which shows up from 550 to 730. So you can see here, this would be our carbon chlorine peak. And so it's having that unusually high carbonyl that is a distinguishing factor for our acid chlorides. Even though we really just look for the carbonyl, if it's a really high frequency, around 1800 or higher, that tells me I have an acid chloride over a ketone. If I have just a carbonyl around 1700, then I would say it's a ketone. When you're trying to determine what kind of carbonyl you have, look for these distinguishing peaks that we've covered so far. Look for the CO single bond, look for the CHs for the aldehyde, look for that OH for a carboxylic acid, look for these two carbonyls for an acid anhydride, or look for the very high carbonyl peak for an acid chloride. If you don't see any of these distinguishing peaks, then you can start to assume you have a ketone. And so our last functional group we're going to cover for our IR spectras is the nitro group. A nitro group contains a nitrogen and two oxygens. Within our nitro group, our nitrogen is a positive charge and one of our oxygens is a negative charge. And the two oxygens resonate back and forth. So we'll see two peaks, one for the single bond NO and one for the double bond NO. And those peaks tend to occur as kind of two daggers coming down like you see here. One of those peaks is between 1300 and 1390. The second peak is between 1530 and 1600. If you see these two peaks coming down, you can start to think you might have a nitro group present. And the two peaks tend to be about the same intensity. And so now we've covered different carbonyl peaks and our nitro peak. After these videos, you should be able to start to interpret your IR spectra. Our next video will go through a few practice problems and see how to start the process of determining which functional groups are present in our IR spectra.